Every difficult math problem hides one important question, not how do I solve it, but what information is missing? If you can answer that question, many difficult problems become surprisingly simple. Let's see why. Here is today's problem. We know that x plus y equals 20 and x times y equals 44. Take a few seconds. How would you solve it? Most students immediately think about substitution. Others try to build a quadratic equation. Both methods work, but they also create a lot of unnecessary work. Instead of asking, how do I find x? Let's ask a different question. What do we already know? We know the sum, we know the product. Now ask the next question. What information are we still missing? There is one obvious piece, the difference. We do not know x minus y. Now imagine, someone secretly tells you the value of x minus y. Could you finish the problem? Absolutely, you could solve it in less than 30 seconds, so our goal changes. We are no longer trying to find x, we are trying to find the missing information. That is how mathematicians often think. Before they calculate, they look for the missing piece. Now the next question is, how can we find x minus y? We need a relationship connecting the sum, the product, and the difference. Instead of memorizing a formula, let's build that relationship ourselves. Start with something familiar. Expand x plus y, all squared. That gives us x squared plus 2xy plus y squared. Now expand x minus y, all squared. This time we get x squared minus 2xy plus y squared. Now compare the two expressions. They are almost identical. The only difference is the middle term. One has plus 2xy, the other has minus 2xy. So what happens if we start with the first expression and subtract 4xy? The middle term changes from plus 2xy to minus 2xy. Everything else stays exactly the same, and suddenly we have built the relationship we were looking for. The square of x minus y equals the square of x plus y minus 4 times xy. Notice what just happened. We didn't memorize a formula, we created it, and once you know how to build it, you never have to worry about forgetting it. Now let's use it. Replace x plus y with 20. Replace xy with 44. 20 squared is 400. 4 times 44 is 176. Subtract them. 400 minus 176 equals 224. So, the square of x minus y equals 224. Take the square root, x minus y equals plus or minus the square root of 224. Now simplify the radical. The square root of 224 is 4 square root 14. So now we know x minus y equals plus or minus 4 square root 14. Look at how much progress we made. At the beginning, we knew the sum and the product. Now we also know the difference. Once we know both the sum and the difference, everything becomes easy. Write the two equations together. X plus y equals 20. X minus y equals or plus or minus 4 square root 14. Now add the equations. The y terms disappear. 2x equals 20 plus or minus 4 square root 14. Divide both sides by 2. X equals 10 plus or minus 2 square root 14. Now use x plus y equals 20. Subtract x from both sides. Y equals 10 minus or plus 2 square root 14. So our two solutions are 10 plus 2 square root 14 and 10 minus 2 square root 14, or the same pair with x and y exchanged. Both represent exactly the same solution, but honestly, that was never the interesting part. The interesting part happened much earlier, the moment we stopped asking, how do I solve this? And started asking, what information is missing? That single question completely changed our strategy. Before you solve your next problem, don't ask, what should I calculate first? Ask, what do I already know? Then ask, What information am I still missing? Very often, that missing piece will unlock the entire problem. That is what we do here at SolveLab. We don't just solve mathematics, we learn how to think about mathematics. Before you go, here is your challenge. Suppose x plus y equals 14 and x times y equals 40. Can you solve it using exactly the same idea? Pause the video, try it yourself, and I'll see you in the next lesson.